Good morning, good afternoon, good evening, whatever and wherever you are. My name is Anna Rochelle, and we are in course 1, chapter 8, day 5. We are solving single step or one step addition and subtraction inequalities. Now, one of the things that you'll notice about today's video is that it is super duper similar from when we were solving single step addition and subtraction equations. And so the same steps that we did with the equations, we're going to do with the inequalities, okay? There's really not much of a difference when it comes to helping us solve the problems, helping us go from step 1 to step 2 to step 3. However, in the very end, we are going to add some additional pieces and not fully just drop it off with x is greater than, x is less than. We also are going to need to draw a number line. So one of the things that I do when I see a problem is actually I just draw a number line right away. So that I don't forget, like, oh, duh, this is one of those times when I need to do that number line, okay? So let's go ahead and let's get started with solving these problems. And so we know that we're going to use opposite operations, right, inverse operations to get our variable by itself, right? So if I'm going to add 3, I'm going to go ahead and subtract 3 on both sides. So I'm going to create this 0 pair, this pair of numbers that shows up as a 0. Then I'm going to end up with x is greater than 7. Now, in the last video, when we talked about graphing these inequalities, what we said what we're going to do is we're going to actually just put the number 7. And we learned that if it's not an or equal to piece, we are going to leave it as an open circle. And because we want all the numbers that are greater than 7, we're going to show our arrow moving to the right. Once we have this piece of information and this piece of information, those two pieces are both part of my final answer, okay? So I can't just leave it as x is greater than 7. I actually have to go in and graph this solution, okay? So we have 9 problems where we can try some problems together. Obviously, I believe fully that if you recall from the previous video, I think it was video 2 or 1 of this particular chapter, you can absolutely go back and watch it again and say like, oh, obviously if I have adding a 5, I'm going to go in and I'm going to subtract 5 in order to figure out what x could possibly be, and then go in and say x is greater than 4. Again, we definitely need to go in and graph the solution. So I'm going to have 4 here. Again, I'm going to have this open circle and go in and to the right because x has to be greater than 4. As you move through these problems, I would definitely love it if you would pause the video, maybe pause it, try one, unpause it, or pause it, try a few, unpause it, so that you can really get to know how to solve these problems and how to graph them a little bit better so that you're practicing as much as you possibly can on your own. So we're going to go ahead and we're going to add 10 to both sides here, just because it's the opposite operation. I'm going to end up with x is less than 11. I'm going to find 11. I know that it's going to be an open circle and all of the less than numbers are on the left. Here I'm going to go ahead and add 15 to both sides, get x on its own. X is less than 19, open circle to the left. Here I'm going to add 1 to create my 0 pair. X is greater than or equal to 5. Here's 5. This will be a closed circle pointing to the right. Closed circle because we know that x could also be 5. Here we're going to subtract 4 from both sides. We're going to end up with x is less than or equal to 3. I'm going to find 3. Make it a closed circle, and then move all the way to the left because it's less than or equal to. Here I'm going to add 2.3 because I know that that's going to create my 0 pair. And then I'm going to be left with 3.2. So I'm just going to put 3.2 in and have a closed circle and make it go to the right because realistically speaking, I could put in here's a 3, here's a 4 and figure out where 3.2 is, but I think you can just leave it as 3.2 on the number line. Here I'm going to subtract 2/9. I kind of feel it might be easier with other types of fractions to do it this way instead of down below, but you know, whatever it is that makes you happy. We're going to end up with 1/9. Again, you can do, 0 and 1 and then figure out where 1/9 is, but no need. Here I'm going to add 1/4. And so instead of really putting in 1/4, I'm going to make common denominators. So make this 2/8 instead. And then I'll be left with x is greater than or equal to 7/10. So I'm going to find 7/10, close circle, and pointing to the right. Here I'm going to add 4/11. Now, options for this particular piece, you can either say that x is less than or equal to 11/9, or you can go in and say x is less than or equal to 1 2/9. Either of those works. It depends on if the instructions say turn it into a mixed number, turn it into an improper fraction, or leave it improper. As we move further on in math, we're going to have a lot more improper fractions in our calculations. So I would recommend just to get used to the improper fractions with your calculations. But if this were a word problem, obviously you're going to go ahead and you're going to turn this into a mixed number, turn this improper fraction into a mixed number. So that way we can actually see the proper way that we're writing things. And that was it. That's really all it is. We're just going in and we're practicing what we did earlier in this chapter and introducing this whole graphing of the inequality. And I will see you in the next video where we talk about multiplication and division, the single step multiplication and division sections. Bye.